Alright, in this video we're going to go ahead and hook up Entity Framework to MySQL. So like I said earlier, Entity Framework does its best job to automatically create the database that it's going to be manipulating, which is really nice for getting started. It's nice for, doing fancy little presentations like the one I did before, talking about how awesome everything is. But when it comes time to actually develop a project, you're probably going to want a little bit more control over where your database is stored, both for deployment to production, but also for development. You might also want to even change what database your Entity Framework instance is going to be using. So in this case, we're going to be showing you guys how to put together support for MySQL, which we will be using throughout the duration of this course. So the easiest way to change where a database or what database our Entity Framework context is going to be used is to provide an alternate constructor to our DB context. You'll see if I go ahead and tell ReSharper to generate a constructor, you'll see there's a variety of different constructors that we can override. For example, we can override our DB compiled model thing, our name or connection string, our name and connection string, and DB compiled model. We can also override existing connections as well, or we can override our object context. The one that we're going to want to override, however, is the name or connection string. This constructor, when overridden, will allow us to change which connection string our database context will use. And our connection string is configured in our app or web.config file, and it tells Entity Framework which database to use. So I'm going to generate this constructor, but I'm actually going to remove the parameter from it. The only thing that I'm going to be using is I'm going to be overriding the call to the base constructor with a string parameter, which is going to be the name of the connection string we want to use. And the connection string we want to use, how about let's say test connection. So by doing that, and now hitting F5, we'll see that we'll have an error. Oh, we should have an error. Oh, you know what it's doing? Wow, Entity Framework really likes to do magic, doesn't it? Let's go ahead and, yeah. Wow, I didn't expect it to do this. I thought it would do an error, or throw an error because there's no connection string called test connection, but in reality what it did was, because there wasn't a connection string called test connection, it decided to go ahead, find my MSSQL server and add a database called test connection to our database. I don't want that. So I'm going to delete the thing that it created. And then we're going to go ahead and actually create a connection string in our app.config that tells Entity Framework exactly where to go for our data. So jumping into app.config or web.config if you're on a website, after config sections, this is important for anybody who's never really modified a .config file before, config sections must appear first in the file. So after config sections, I'm going to add a connection strings element. Inside of our connection strings element, I'm going to add an add, and then I'm going to give it some properties. The properties we want are name, connection string, and provider name. So what are these three attributes? Well, the first one is the name of our connection string. How do we want to reference this connection string from elsewhere in our code? Now, the name of the connection string I want to use is the connection string name that I'm passing in to the base constructor of our test context, which is called test connection. So I'm going to type in test connection. Now I'm going to hit F5 and we better get an error. I'm going to be upset. There we go. It says the connection string test connection in the application's configuration file does not contain the required provider name attribute. Well, it does, but it's empty. Okay, so good. We finally got the error that I was looking for. Now, the other two attributes we have to fill in is going to be the connection string itself, as well as the provider name. And the provider name is the name of a class that's going to be used to connect to the database under the hood. And the provider name's effectively going to specify what kind of database we're connecting to. For example, an MSSQL database, a local DB database, or a MySQL database, or an Oracle database, or whatever it supports, which is pretty much everything. So let's go ahead and do that. I'm going to fill out the connection string first. Now, connection strings actually follow a different format depending on what kind of database you're connecting to. If you go to connectionstrings.net, this is an excellent reference that'll tell you the connection strings you need to use for particular kinds of databases, and you'll notice there are quite a few. If we go ahead and look at MySQL, we will see some of the default, or not the default, but the most common connection strings we can use with the MySQL provider. Again, connection strings are provider specific, so your connection string to MySQL or MSSQL won't magically work if you just change the provider name to something else. So that's the standard thing, and that's what we're going to follow. So I'm going to say connection string equals server equals localhost, because the MySQL server that we're going to connect to for development is on my local computer. Database equals, let's say, test_MMO. That's going to be the database name within our MySQL instance. UID is going to be root, which is my root account. And now all of you guys will be able to see the root password that I use for my local MySQL database, which is not in any way exposed publicly, nor it ever will be, because my password is actually Nelson. Yes, my password to my root database, MySQL database, is my name. It's easy to remember. And technically that should be all you need, but there is one additional property that we're going to have to add in order for it to work properly with Entity Framework, and that's going to be allow user variables. I'm going to set that equal to true. Okay, so again, you will have to install MySQL, by the way. So go ahead and grab MySQL. Make sure to grab the MySQL workbench as well. Actually, technically, my server isn't a MySQL server. It's a MariaDB server, which MariaDB is a fork of MySQL, but better. But anyway, that's irrelevant. This will work regardless if you use MariaDB or MySQL. The provider name, again, is going to be the name of a class. And the class is mysql.data.mysql_client. And that name we'll configure this name later to actually reference a class that will allow us to work with MySQL. But we're not done yet. If I go ahead and hit F5, we'll have some problems. First, it'll say the ADO.NET provider with invariant name mysql.data.mysql_client is either not registered in the machine or application config file or could not be loaded. See inner exception for details, which the inner exception is unable to find the requested .NET Framework data provider. It may not be installed. There's a chance that you might not get this error, and I'm sorry if I'm being a little meticulous about writing a little bit of code, then running it to get an error, but I'm doing that because there are many different errors you might get depending on the circumstances, and I want to discuss as many of them as possible so that people can be able to fix their issues. When I said you might not get this error, you might be getting a different error. That might be if you have gone to MySQL, the MySQL website, and installed the connector globally on your machine. We don't want to do that. I discourage people from installing the MySQL database connector on your machine. I encourage people instead to install a specific version of the MySQL data connector for every project that you will be using MySQL with. That's because I've been working with MySQL data connector for a very long time, and different versions of it will cause different things to break. You will run into a dependency hell situation if you rely on your computer having it installed globally, because you might have one project that requires a specific version, as well as another project that requires a different version. So I encourage people instead to follow the steps I'm about to show you to install the connector directly to this project and this project only. This has the added benefit of being able to deploy this project to any computer, regardless of whether or not it has the connector installed globally, which is a good thing. So what we're going to do is we're going to pull down the NuGet package for MySQL and install it locally to this project. So I'm going to go up to References, hit Manage NuGet References, and I'm going to type in mysql.data. Now we'll see a couple entries. The one that we want is going to be our mysql.data.entities. We also have our .entities.ef6, but I believe this is a temporary package. This is when Entity Framework 6 support was still in beta, I believe. We want the mysql.data.entities. This will pull in, by hitting install, it'll pull in the mysql.data package as well as the Entity Framework package, which we already have pulled in. The mysql.data package is the base connector. So if you're working with an Hibernate or another ORM, all you'll need is the mysql.data package to work with MySQL. However, the mysql.data.entities package provides support for Entity Framework 6. You'll note right here it says this package does not contain EF5 support. But fortunately for us, it'll also pull in the required mysql.data. So if you're working with Entity Framework, this is the package you want. And that kind of flickered through the screen really quickly. I hit install, so now it's installed. So then hit close. All that really happened here is we have some added references. We have the mysql.data reference and the mysql.data.entity.ef6 reference. Now it's very important that you make sure that both of these properties of both these objects are set to copy local true, which should be the default. Never set copy local to false. Copy local will copy these assemblies to your output directory because we need the mysql.data DLL to be sitting right next to our project in order for a local installation of MySQL to work. When I say local installation of MySQL, I mean in order to not install it globally. However, that's still not enough. It's never enough, is it? We still get...
Not ever.
No, never, 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 especially with code. We still get our same error. That's because we've installed the DLLs, but we haven't actually told our app config about the DLLs. So let's jump into our app config, and let's first tell it about the MySQL connector. Okay, in order to add a new connector to a local project as opposed to relying on the global connector, so again, even if it's working for you right now, that means it's using your global installation of your MySQL.data. You're not using your local installation of your MySQL.data, which means that there's a potential, if you do not follow the steps I'm about to show, there's a potential there'll be a massive version mismatch and everything will break and the world will end. So make sure that you type this stuff in. We're going to add a new element in our configuration called system.data. Inside system.data, we're going to type in db. Oh, great. It's not going to provide me IntelliSense for this, is it? DB provider factories. Inside of DB provider factories, we're going to type in add. Now we're going to provide quite a few different attributes to this add element. We're going to have name equals blah. And then we're going to have invariant equals blah. Then we're going to have type equals blah. So these are the three attributes we have to fill in when we add a new DB provider factory. The name, we're just going to type in MySQL data provider. That's easy enough. The invariant is going to be the kind of the name of our provider, which is going to correspond to the provider name we put in our connection string. So the invariant name is going to be mysql.data.mysql client. And finally, we have the type. This is the most important field. This will tell it what class and what assembly to load the MySQL data provider from. Okay, the class name is going to be MySQL. I dropped out, didn't I?
Yep.
Well,
right at MySQL.
Which one? There's like 1, 2, 3. No, it doesn't matter. I was just spelling out what I was typing. The type is MySQL.data.MySQL factory. Then we have to tell it which assembly to load this type from. So we add a comma, then we say MySQL.data. Now I'm going to see if we can get away without providing a version number or a public key token. I don't know if we can get away with not providing that, but technically we should be able to, because this MySQL.data assembly is going to be copied to our bin folder. So we won't need to reference anything in the GAC. So we'll see what happens when I hit F5. Now we should still get an error when I hit F5, but hopefully it'll be a different error. Yep. We got a different error. We got required attribute description is not found. Well, that's not the error I wanted. Sorry about that, guys. There's actually another attribute we're going to have to add to our DB provider factories. I'm trying to make this as simple as possible, and I could have sworn the description was a optional attribute, but it turns out it's not. So I'm going to say description equals, and description is going to be ignored by everybody for all intents and purposes. But let's go ahead and type in .NET Framework Data Provider for MySQL. Okay, let's hit F5 and we should get a different error. All right, sweet. We have successfully registered our MySQL data provider to .NET. So now .NET can locate MySQL connections. However, we have not told Entity Framework that there is an Entity Framework provider for our ADO.NET provider. That's because this bit only tells .NET how to connect to MySQL databases. It doesn't actually hook MySQL up into Entity Framework. To do that, we're going to have to add a new attribute, a new element to our providers element right here in our app.config, which one has already been provided for us, our SQL client. So let's go ahead and add our MySQL provider. That's going to be a provider element, and again, I'm not getting any IntelliSense, which is kind of annoying. We're going to need an invariant name, invariant name equals, and then we're going to need a type equals. Okay, so what's our invariant name? Our invariant name is the same thing that we've used for our connection string as well as our DB provider factory, and that's going to be MySQL.data.MySQL client. Next, we need a type. This is going to be the type, or the class, that Entity Framework will load to manage the entities. And the type is going to be MySQL.data.MySQL client.MySQL provider services, MySQL.data.entity.ef6. Okay, so the first thing is we have a class. Make sure that this is MySQL provider services. Earlier when I was testing out what I wanted to do in this video, I mistyped that as service. That's very easy to mistype considering it's just an S. But this is a class that will tell Entity Framework how to work with the MySQL data provider. Then we have a comma, then we have an assembly name. And this assembly name corresponds to this assembly that was pulled in from NuGet. So again, that assembly is going to be sitting side by side with the rest of our binaries. It's going to be sitting there as a DLL, and this provider element is going to tell Entity Framework to load that DLL up, grab this class out of it, and use it to interact with our database. Okay, let's go ahead and hit F5 and see what other errors we can get. Now we get the specified key was too long. Max length is 767 bytes. And that's going to be happening up at execute reader, next result, get result, driver's result. This is going to be something a little fun with using MySQL instead of MSSQL. So I want to go ahead and leave this in while I debug this issue. And that is that primary keys and foreign keys have different or unique keys. Can only be a specific length for MySQL, whereas that length in MSSQL is different. So let's go ahead and close out our connection. I want to figure out where that error came from. Did that error come from us loading our users, or did that error come from running our migrations? So let's go ahead and debug that. Let's say update database and see what happens when we try to update our thing. No migration SQL generator found for provider. Use set SQL generator method in the target migrations configuration class to register additional SQL generators. This might be one of the reasons why we got that error earlier. So let's go ahead and fix this error first when migrating our database. To do that, one of the things that we're additionally going to have to do in our app.config is tell Entity Framework certain things about the way that MySQL will work as opposed to MSSQL. And we do that on the Entity Framework element by adding an attribute called code configuration type. And we'll set that equal to mysql.data.entity.mysql ef configuration casing matters, by the way, guys, comma mysql.data.entity.ef6. Okay, so this will tell Entity Framework about certain conventions that we want to use that are different between MySQL and SQL Server. I'm not sure if it'll fix this error with the migrations, but it will get us a step closer. So I'll go ahead and update database again. And we get some stuff. Okay. Oh man. You guys are so confused right now, I bet. This
I know I am.
This database actually already exists, doesn't it? I bet it does. Let's try test MMO 123. There we go. That's what you guys would have gotten. Okay, what I'm going to do is I'm going to go ahead and open up my MySQL Workbench, and I'm going to nuke these databases that have been automatically created by Entity Framework for us. It's been doing a lot of magic behind the scenes, and it's starting to make things a little confusing because of all the stuff it's doing behind the scenes. The different combination of errors that we're getting is, it actually makes sense when you think about it, but at a top level, it might confuse people. Okay, if we open up MySQL Workbench, which opened up on another screen for me, and open up our local instance, I'm going to go ahead and delete a couple of these databases. I'm going to drop blog. That's something I did for testing. I'm also going to delete test MMO, drop schema. I'm going to do test MMO 123, which is also created, drop schema. And then I think that's it. That's all I have to nuke. Okay, so now that we've nuked all of our databases, so we're sure we're working with a fresh database, I'm going to go ahead and I'm going to say, for my connection string, I'm going to say test project, or how about entity framework test? How about test underscore entity framework? There we go. So that's going to be our database name. So now that we've done that, we are not going to run update database again. And the reason is we have a problem with our migrations. It says the underlying provider does not support the type nvarchar max. And that's because in MySQL terms, we only have varchar columns. We don't have nvarchar columns. Nvarchar columns are specific to MSSQL. And what they are is they're Unicode columns as opposed to ASCII columns for text. Which means we're going to have to go into our migrations and modify the bits that reference nvarchar. Which we're going to have to modify our strings right here. All right, and we're back. Slight issue. I believe I've just uncovered a bug. Now, I think the bug, my theory about the reason why we're having an issue is because of the way Entity Framework's migrations work. What I believe happened is that because previously we were generating migrations that were specific to MSSQL and not MySQL, and then we switched our code configuration type to MySQL from MSSQL, all of these existing migrations are not going to work properly. The reason that is because, or I believe the reason that is, again, this is unfortunately a bug that I wasn't actually able to find anything online about, is that our Entity Framework actually stores a snapshot of your model inside of a regex file in the migration. You'll see that every single migration is a CS file, a design CS file, and a regex file. So there's actually 3 files generated per migration. And now the problem is that our, I believe the problem is that our regex file unfortunately contained MSSQL specific code in it because we were previously generating our migrations with MSSQL as opposed to MySQL. Fortunately, switching databases doesn't happen very often, and if it does, you can go through the trouble of doing things manually. But in our case, because we weren't very far along in development, and this is also a throwaway project, we can fix this problem simply by deleting all of our migrations and recreating them. It's also important to note that I have also cleared out our test entity framework project. Make sure that your test entity framework project has no tables inside of it. Otherwise, you might have a bad time. So coming back into Visual Studio, I'm going to delete our existing migrations. So I'm just going to come up here and hit delete. Then I'm going to say add migration initial. Hit enter. Wait a year and a half. And we get our initial migration created for us. So this is just basically a snapshot of our model as it exists right now. Now the next step, of course, is going to be to update our database. So I'm simply going to do update-database and hit enter. And that'll run that migration, and you see it completes without any errors. If I come back over to MySQL Workbench, right-click, hit refresh, we will see our tables are indeed being added. So let's go ahead and see if our data works. If I hit F5, we should be prompted for a username, which we are. I'm going to hit enter and we close. I'm going to hit F5 again. We should see that user we just inserted, which we do. And let's add another user. Let's hit F5 again to run again. We should see 2 users now, and we do. So coming back into MySQL Workbench, let's see if the data properly came over here, or if Entity Framework is doing some other magical thing and created some random file in my file system to store the data in. Let's right-click users and hit select rows, and indeed we do see our users. I could even come in here and add a custom user from Workbench, whatever. Hit that, hit apply, and we now have a new user added in from MySQL Workbench. If we come back over to our program, hit F5, we should see that user, which we do. Okay, let's go ahead and do something. What kind of data do we want to add? I want to just show the process of creating another migration with MySQL and also to verify that it's going to work. What else do we need? We need the concept of an item. Our inventory item is just an item in a character's inventory, but we should also have the concept of a actual item, like basically the master, the prototype of that item. So what I'm going to do is I'm going to delete the name. Then I'm going to add a new entity called item. I'm going to give it a public int ID, and then a public string name. Mark it as required. So now I have my item class, my item entity. Now I'm going to go over to inventory item, and I'm going to say public virtual item, and I'm going to give it a required. So our item is required. And then I'll also, because our inventory item represents an item in the character's inventory, we might be interested in knowing what item slot it's in. So let's say inventory slot right here, and also mark this as required. Now, because we added a new entity, we have to go into our context and add it, although we didn't have to do it for our inventory item because it was referenced by character, so it was automatically brought in. We won't have to do it for the item either because item is referenced by inventory item, But for good measure, it's really important that we add a DB set for all of our entity classes. So I'm going to say public DB set items, and then I'm also going to add our inventory items too for good measure, even though this won't really affect anything. So inventory items. So now let's add a migration. So I'm going to say add migration, add item entity, and hit enter. As you see, we now have a nice little migration that was automatically generated for us that'll modify our database structure to reflect the changes we made to our entities. Notice that it does indeed drop the name from the inventory items. Then I'm going to say update database and hit enter. It applies the migration. We come back here, we right click, we say refresh all, and indeed we now have an items table, and our inventory items now has an item underscore ID as well as an inventory slot. Okay, so that's getting MySQL to work with Entity Framework. Again, just to recap the steps, the first thing we do is we have to add our reference to MySQL.data and MySQL.data.entity.ef6. The next thing we have to do is in our app.config, we have to tell .NET about our new DB provider factory, which in this case is the MySQL data provider. Then we have to tell Entity Framework about our MySQL client provider, which we do right here. Then we have to tell Entity Framework to use the code configuration of MySQL as opposed to the MSSQL code configuration. And then finally, we add our connection string, which references the MySQL.data.MySQL client provider. Once we give our connection string a name, we can inform our database context to use that particular connection string by overriding its default constructor and passing the connection string name into the base constructor. And that's it. The only caveat is that if you generate migrations using MSSQL and then switch over to another database, you will probably have to delete and recreate those migrations. There should be easier ways to do that, but in reality, in production, not once have I ever moved a database between one type to another. I've never started a project on my MSSQL and ended up on MySQL. I never started a project on MySQL and ended up on Oracle. That typically doesn't happen, mainly because we typically have a lot of database-specific code in our application, and we also depend on certain features of a database. Because if there weren't different features between databases, then why would there be multiple databases on the planet? So, generally speaking, I don't see that bug as a showstopper. So what? It makes it so that we generate a bunch of migrations against MSSQL, then it throws a fit when we migrate over to MySQL. That is not a big deal. Anyway, hopefully we went through all the steps as clear as possible, and hopefully we showed a couple errors that you guys might have ran into while doing this. I guess we will see you guys in the next video.
Woohoo!